All right, guys, today we're going to look at rotations. This is the last section of our transformations. Go ahead and sign in, and we're going to start this together. So first, what exactly is a rotation? A rotation is a transformation in which a figure is rotated or turned about a fixed point. The center of rotation is the fixed point. A rotation does not change size or shape of the figure. So the pre-image and the image are congruent. But orientation is not preserved because the figure is turned. So there's some key points in here that I want to point out. First, a rotation is just a turn. It means you're turning something. Because you're turning, so think about yourself. If I am, let's see if I can do one of these sticker guys. So if I put this sticker here, and then I want to turn it onto its side. I don't think I can turn it onto its side, but if I turn it onto its side, the little heart and the eyes are going to be on its side now. So let me show you what he might look like if I was to draw him. So if I draw him, so he's now going to be here, and now he's going to be on his side. This is hard eyes right there. So he has turned to his side. You see how because he turned, the orientation has changed. His direction has changed. So because the direction changes, the orientation doesn't stay the same. But his shape and his size stays the same. So that means that it is congruent. So let's answer this first one. It says a rotation does what? It turns. So I'm going to say that it turns. And then let's match these from last week or the previous weeks. So a translation, that's your slide. A reflection is a flip. A rotation, our new transformation, is a turn. And a dilation, that's when we reduce and enlarge. So looking back at what we just talked about, true or false, a rotation is congruent. It is true. It means that it stays the same shape, the same size, all of its angles stay the same. So if I look at this one, it says a transformation is applied to a figure on a coordinate plane to create a new figure. Which one of these transformations preserves congruence? Last week, some of us were kind of confused when we saw those words preserve congruence. We didn't know what that means. All that means, remember, is same size, same shape. So preserves congruence, same size, same shape. Everything is the same, and some words we might see are equal. So that is a rotation. A rotation, we know same size, same shape is going to be a rotation. We also learned that if I think about the cheat sheet, let me go down here. The cheat sheet that we created, I included it as well. The only one that isn't congruent is the dilation. So let me add that up here. So that means that the rotation maintains congruence, the rotation, the reflection, and the translation all maintain congruence. They stay the same size and the same shape. So if I look here, a reduction, that's a dilation. A dilation does not maintain its congruence. That's the only one that does not stay congruent. So a reduction, that's a dilation. So that's out. An enlargement, that's also a dilation. That's out. Rotation, here's my rotation. You're good. And then my dilation, again, that is out. So I am looking at answer choice C. Now let's move on. Number 7. A rotation of 90-degree clockwise is applied to a new figure on a coordinate plane to create the new figure. Which one of the following statements is true about the new figure? So let's see. We're talking about a rotation. So let me write down what I know about a rotation before I read these answer choices. A rotation, it maintains congruence, but it does not keep its orientation. It's not an orientation. I'm going to say the orientation changes. Let me erase that. Where's my eraser? They moved everything. So the congruence stays the same, keeps its congruence, but its orientation changes. So let's look at the answer choices. The first one says the new figure will be congruent to the original figure. And what did I say? Congruent, true. What are we looking for? True. So I'm looking at A is going to be the answer. Let me go to the next one. The corresponding angle measures of the original figure and new figure will not be congruent. That is not true. And real quick, let me point that out. I noticed some of you last week were getting confused on the angles. So think about if I have a sheet of paper, maybe a Post-it, and then I blow it up and I make it into an even bigger piece of paper. So even though it grew, you see how it still has right angles. The angles stay the same. So the angles don't change in the transformations. All of your transformations will not change your angles. So this guy's out. The new figure will be congruent to the original figure, or will not be congruent, but it will be congruent. That's out. And then the last one says the corresponding side lengths of the original figure and new figure will not be congruent. We were looking for congruent. So the only one that could be the answer there would be answer choice A. And then let's look at this one. So this one again is talking about the angles. So I want you to take a moment and see if you can answer that one. So true or false? A rotation's orientation is preserved. False. False. The orientation changes. So this is false because the orientation changes. So if you look at your answer choices, we're not looking for true. Let's see, false because the direction changes. False because the direction stays the same. The orientation changes, that means the direction changed. So this is your true one, this is your false one. Okay, let's go on to the next one. All right, so here, this is where things get a little weird, a little funny. I'm giving you the rules here, but I'm going to show you in a different video how to find these rules, how these rules work, a little trick, because you're going to have to memorize these rules. And if you don't memorize them, I'm going to show you a way to memorize them. So hopefully you can remember how to come up with these rules. So a 90-degree rotation, notice how right here, let me get my pen. The 90-degree rotation is right here. You see how it turned? It started here and it turned over to here. So that's a 90-degree rotation. And the rule is going to be XY turns into Y opposite X. Y opposite X. So that's going to be this first one. The next one says 180. So your X and your Y are going to become opposite. And then the last one is a 270. So let's look at these degrees. What are they talking about? So this was a 90-degree turn. You see how this one, it turned 180. So it turned 90 and then 90 more. And then here it turned 90, 90 more, 90 more. So we ended with a 270. So this is an opposite Y, opposite X. So what does that mean? So let me show you. If I have a vertex that is at, let's say point A is at 2, 5, and I want to do a 90-degree rotation. So what that means is my XY is going to turn into, right here, XY is going to turn into Y opposite X. So what that means is my X and my Y, they're going to flip. The Y is going to come to the front. This is saying your Y needs to come to the front. So my new A prime, my Y comes to the front. That's going to be a -5. Oops, sorry, not a negative. That's a +5. I'm just flipping them around. Let me fix that. So my 5 comes to the front, my 2 goes to the back, and that's because this is saying the y needs to be in the front, the x is in the back, but it's saying the x needs to be opposite. So because the x was originally a positive 2, now it's going to become a negative 2. So let's try another one. Let's pretend that now I'm going to do a 180 turn. Let's do a 180. So write this down. We're going to say b is at, I'm going to say negative, I'm just making stuff up, negative 5, 3. So this is where my original b is at. This is my xy. And I want to do a 180 change. So a 180 says I'm going to have an opposite x and an opposite y. So let's see. All that means is, well, my x and my y are staying in the same place. So my 5 and my 3 are staying in the same place, negative 5 and 3. But now I need the opposite. So the opposite of negative is positive. The opposite of positive is negative. So that would be a 180 rotation. And then last, a 270 rotation. Let me show you what that would look like. So this was a 90 degree. This was a 180 degree. And then a 270 degree. And I'm going clockwise. I'm going clockwise. I could go counterclockwise, but everything would just be backwards. So I'm going clockwise. So now I'm doing a 270. So the 270 rule says my xy is going to turn into opposite y and then x. So let's put an original xy, I'm going to say C. Point C is going to be at, let's do some negatives, negative 5, negative 6. So now I want to switch them around. This tells me that I need my y in the front and my x in the back. So this was my original xy. So again, the rule tells me to pull the y to the front. Let's see, y comes to the front, x goes to the back, and which one needs to be opposite? The y. So the y was originally a negative 6. It becomes a positive 6 now. We're going to practice some more of those. So let's continue. All right, let's try it here. So this one says the original vertices are located at A, which is negative 8, negative 4, B, 3, negative 3, negative 3, and then C, negative 3, negative 7. So let me write those down. A was at negative 8, negative 4. B was at negative 3, negative 3. And C is at negative 3, negative 7. And what kind of rotation am I doing? Let's see. Determine the images of the vertices of the triangle ABC after a clockwise rotation of 90 degrees about the origin. So I'm doing a 90-degree rotation. So my 90 degrees, my rule is y opposite x. Write that down. So my xy is going to turn into y opposite x. And if you need to see that again, the rule is right here, y opposite x. I left it there for you. Okay, so what does that mean? Well, that means that I need to flip my x and my y. So a prime becomes negative 4, negative 8. And I like to do the opposite one at the end. So I flipped around, told me to flip, and it said that the x needs to be opposite. So the 8 becomes a positive 8. This is a 4, it looks funny. So negative 4, 8. And now let me do this one. So this, again, my rule says I need to flip my x and my y around. So it looks like it's going to be the same until B prime, until I make my x opposite. So x opposite becomes positive 3. And then C prime, I need to flip my x and my y around. So 7 comes to the front, negative 7, negative 3 goes to the back. And then again, my x is supposed to be opposite, so that becomes a positive 3. So the points I'm looking for are A prime at negative 4, 8, and B prime at negative 3, 3, and then C prime at negative 7, 3. See if you can find that answer choice. Negative 4, 8. So negative 4, 8, look how they have positive here. So positive, you're out, you're out. Negative 4, negative 4, 8. So all these A's look good. Let's go to the B. So it should be negative 3, positive 3. Negative 3, positive 3. Positive 3, negative 3. Backwards. Negative 3, positive 3. So far A and E are my two good choices. Let's do the last one. Negative 7, positive 3. Positive 7, negative 3. Nope. Negative 7, positive 3. Yes. So my answer choice for this one would be E. And then what I did was I put the cheat sheet here. I just updated it for you. Go ahead and use that to help you. And y'all are going to continue these next, I believe it's 5 problems. And then the next few days, you're going to do similar problems to these. And I did include the cheat sheet for your assignment. And that is it. So I'll leave it here for you. That way you can use it. And let me know if you need help. Make sure you log in if you need help.